Yes, children. So let us see preparation of aldehydes. Now, aldehydes can be prepared from various sources. First of all, you can prepare it from primary alcohol. This you have already studied in alcohol chapter. Primary alcohol, when you pass the vapors of alcohol through a copper tube at 573 Kelvin, you can get aldehyde. Or if you are using Jones reagent, the CrO3 bar dilute H2SO4, this is called as Jones reagent. This is also a weak oxidizing agent. This can also be used. Or you can even use acidified dichromate, that can also be used. Or you can use PCC in the presence of dichloromethane as solvent. This can also be used. Okay, so primary alcohol can be converted into aldehyde. And what is the advantage of PCC? I've already told you. If at all there is a double bond in the carbon chain, that will remain unaffected, or that will not be oxidized or do anything if you are using PCC. Okay, if you are using any other oxidizing agent, the double bond in the carbon chain can also get oxidized, but in the presence of PCC, nothing will happen. Then you can prepare it from ethyne in the presence of water and dilute H2SO4 and HgSO4. Okay, this you can prepare. Again, this also you have studied in 11th class. Then alkenes on ozonolysis followed by hydrolysis in the presence of zinc dust, you can prepare aldehydes. Then you can also prepare it from cyanides, alkyl cyanides with SnCl2 and HCl. This is called as Stephen's reduction. That can also give you aldehyde. Then you can also prepare it from acid halide in the presence of palladium and barium sulfate when hydrogen is added to acid chloride. This is called as Rosenmund reduction. Okay, you can get aldehyde. Then you can also use a mixture of acids. Mixture of acids means this formic acid is compulsory. You have to use formic acid, only then you can get aldehyde. Now how? See, I have taken two molecules of acid, RCOOH and HCOOH. I told you formic acid is compulsory. Now when you subject it to catalytic decomposition, that is in the presence of manganese dioxide at around 573 Kelvin, what happens is CO2 and H2O, see, put together CO2 and H2O, they get removed, and what is left behind is RCHO. Okay, so you can get aldehyde, right? That is one way. Then from calcium salt of acid, also on distillation you can get aldehyde. How? Now the limitation here in the case of calcium salt of acid is you can prepare only formaldehyde, no other aldehyde can be prepared. Okay, now what is calcium salt of an acid? This is calcium formate, HCOOH, HCOOH, calcium is divalent, so you get calcium formate. Now this calcium formate, when it is subjected to distillation, what happens? An insoluble salt separates out. Which is the insoluble salt? CaCO3. Calcium carbonate separates out, and what is left behind is formaldehyde. Is that clear? Now supposing you are using calcium acetate, then here it will be CH3 and CH3. So in that case, what will get? You will get CH3CO CH3. That means a ketone will be obtained. So unless you are using calcium formate, you can't prepare aldehyde. So this is one restriction here or limitation here. Then from RCN, just like your Stephen's reduction, from RCN by using another reducing agent called dibyl H. What is dibyl H? Di-isobutyl aluminium hydride. D for di. Two isobutyl groups are there on either side of aluminium and one hydrogen. You know, aluminium is trivalent, is it not? So aluminium के साथ एक hydrogen है और दोनों side isobutyl group है. That is called as dibyl H. It's a reducing agent. Followed by hydrolysis, you can get aldehyde. Same way, the same dibyl H can also be used on esters. It can also be used on esters. You can get aldehyde. See here, when you are using an ester and in the presence of dibyl H, this RCO part, this is getting reduced to RCHO. Okay, so from RCN and ester, you can use this diable H to get aldehyde. Then the last one is Backer's process. This Backer's process is prepared from alkenes. Okay, now what do you do there? Say ethene, it is treated with aqueous palladium chloride. In the presence of CuCl2 as catalyst, you will get aldehyde plus HCl plus PD. Now what is the advantage here is the PD that is formed, that can be converted to PdCl2 again and can be used with another molecule of alkene. Is that clear? So that advantage is there. PdCl2, a very small amount if you use, that is sufficient because it can be regenerated and used again and again, right? So that is one advantage for Backer's process. Anyway, Backer's process is not there in your textbook. You need not have to worry. Rather, this calcium salt of acid and all that is also not there, but it's better you know this calcium salt of acid as a method of preparation. It's better if you know it. Okay.